Hi everybody, it's Guy, the FizzWiz Guy. I'm going to talk about the importance of bubble size during the carbonation process. There's three main ways to control your bubble size. The first one is the size of your carbonation stone. The second one is the size of the pores inside your carbonation stone. And the third one is how quickly you flow the CO2 through your carbonation stone. On the FizzWiz, we use a flow controller and we measure that in cubic feet per hour. So let's take a look at the FizzWiz setup. Here we have a FizzWiz mounted on the arm. If I start here, we have the CO2 inline coming from a pressure regulator set to about 25 to 30 pounds per square inch. The next line here is a 1/4 inch pneumatic hose that goes to the top of the carbonation stone. After that we have the connection that goes to the CIP arm via this little clever device which we call a separator. And at the bottom of the separator there is a little sight glass, and that's really important. We'll come on to why that's important in a moment. The next thing we have is a temperature sensor, and the temperature sensor has to go into its own dedicated thermal well in the tank, and that can be done in three ways, either via a spare thermal well that you already have in your tank, or through a thermal well adapter by modifying the sample port, or by using the WizStone combo. And there's some videos at brewwiz.com about those different options. Okay, so let's talk about bubble size. There's three things going on with bubbles. So let's talk about big bubbles first. We're going to represent big bubbles by using these beer mats. Okay, so big bubbles, what's the problem with big bubbles? Well, the problem with big bubbles is they have lots of buoyancy. So big bubbles tend to go to the headspace really quickly. So as they come out of the carbonation stone, you'll find that they'll just go up to the top of the headspace really quickly, and they won't dissolve into the beer. So let's talk about small bubbles. We're going to represent small bubbles by these beer caps. So small bubbles don't have a lot of gas in them, so they don't have a lot of buoyancy. So as they come out of the stone, what they tend to do is they struggle to get their way through the beer, and they tend to just hang around in the middle of the tank or at the bottom of the tank until more CO2 comes along and pushes it to the headspace. So small bubbles don't have much buoyancy, so they don't go to the top very quickly, which means that they have more residency time. They spend longer time in the beer, so more opportunity to dissolve into the beer. The second thing is surface area. So we can represent surface area by using a beer mat. And if you can fit lots of little bubbles into the area where one big bubble is, then you will have more surface area for the same amount of gas. So I can represent that by putting lots of bottle tops onto a beer mat. So clearly smaller bubbles have more surface area. So the more surface area you have, the more opportunity again you have to dissolve those gases into your beer. It's very similar to dropping either a big ice cube into a glass of water, which takes a long time to dissolve into the water, or crushing that ice cube up. And if you've ever done that, which I'm sure you've had when you've enjoyed a gin and tonic or something like that, I'm sure you'll see that crushed up ice dissolves very quickly into your drink, whereas one ice cube doesn't. So same principle, just clearly more surface area, more opportunity to dissolve. The next thing is small bubbles have huge amounts of pressure on them. So you have to think about this within the tank. Within the tank, you've got your beer surrounding the bubble. This bubble is staying in the solution longer, and it's being crushed by the weight of the beer. Because if you think about it, there's way more mass of beer compared to the size of the bubble. bigger bubbles, the ratio is far smaller. So there's not as much pressure pushing onto the bigger bubbles. The bigger the pressure differential that you can create, then the more opportunity you have to create equilibrium within your beer. And this principle is called Laplace pressure, and you should Google it. Very small bubbles can have incredibly high pressures in them. So a bubble about the size of a cat's whisker can have anything from like 30 to 100 pounds per square inch inside the bubble. So if you can get all those working for you, you now have bubbles that want to dissolve into your beer. And as I said on the FizzWiz, we control bubble size by using the flow controller in cubic feet per hour. And there is a video on brewwiz.com which explains how to calibrate each stone individually using the flow controller. So the other thing I should tell you as well is that some beers are more likely to have foaming on the top, and big bubbles cause terrible foaming on the top of your beer. So things like a stout are more likely to have foaming at the top. So that means you need to go even slower and have even smaller bubbles with something like a stout than you would do if you had something like a Pilsner, for example. So, okay, through the magic of animation right now, using the FizzWiz, we're going to now try and demonstrate what's going on in the tank. So let's go ahead and turn the FizzWiz on. And let's select carbonation mode. And we're just going to set it for 2.4 volumes, which is the default. And we're going to press go. So the FizzWiz is going to start. And I've set the flow rate on this stone. Well, let's set it to 1 cubic feet per hour. So let's draw a big hole in this tank right now. Oh, look at that. So now we can see what's going on inside the tank. And you can see down here, coming from the carbonation stone, we've got tiny little bubbles. And they're just going into the beer, right, very, very locally. There's more CO2 and they're sort of getting pushed around. So nothing's going to the headspace because there's no buoyancy in these bubbles, because we have the flow rate super low. So let's turn the flow rate up a little bit. So let's go to 4 cubic feet per hour. So now you can see the bubbles are getting bigger. Okay, and some of the bubbles are staying down here, but now more and more of the bubbles are coming to the top of the tank. And less of these bubbles are dissolving into the beer and more are getting to the headspace. Okay, so let's turn it up really high now. So we're at 8 cubic feet per hour now. And now look at the bubbles. All they're these horrible big things, and none of them. We've got less of this like speckly, cloudy stuff down here, and the bubbles are all just going to the top of the tank. And oh no, look at this, what's this? There's foaming going on in the tank. But of course, in the real world, you can't see that foaming. You can't see the foaming at the top of the tank. So when do you know that you are going too fast with the carbonation? Well, that's why we put on this sight glass. Because now you can see that there's beer dripping into this sight glass. And that's an indication that we are carbonating too quickly. Now, when this happens, you are going majorly too fast. Your bubbles are majorly too big. So the only way to resolve that is turn the flow rate down, at least half to what it was. And now you can see the bubbles are getting smaller in the tank again. And as the bubbles getting smaller in the tank, then, you know, our carbonation and gas transfer is good. So, if you need to go faster, the way to deal with that is not to turn the flow rate up. The way to deal with that is to create more small bubbles. So going back to the beginning, when I was talking about the 3 main ways, if we increase our carbonation stone length, then we will be able to flow at a higher cubic feet per hour, but we will not create big bubbles on our stone. So, that's the talk about bubbles. I hope you found it interesting. If you've got any questions, give us a call.